In this lesson, we're going to look at trig equations that may require us to use some identities that we have learned in the past. So let's just review those Pythagorean identities. Those three. That helps you relate the cosine squared with sine squared and tangent squared with secant squared and so forth. And then we have double angle identities that lets you change a 2 theta in terms of just 1 theta. So these equations, we're going to be looking for two things. First of all, we want to make sure we have the same trig function. That is always nice. We want to have either all sines or all cosines or all tangents. And we also want to make sure that we have the same angle. We don't want to be dealing with a 2 theta and a 1 theta. Very difficult to solve. Then of course all the things we've talked about in the previous equations, we need to be careful of our interval, expressing our answers the correct way. So let's just look at this first example. Notice we have tangent squared and secant squared. So we want to have that same trig function. So you ask yourself, how could I change the secant squared into tangent or tangent into secant? Now personally, I would rather work with tangent because those are the values I kind of know a little bit better in my unit circle as opposed to secant. So let's see, secant squared theta is equal to 1 plus tangent squared theta. So I want to substitute that in right here, and I want to be careful of that negative sign. Then I'm going to distribute the negative sign. And I'm going to collect like terms. And now my equation looks a little bit easier. Now over here on the graph, I've graphed from 0 to 2 pi, and I went ahead and graphed this equation under y1 equals, and then of course this is y2. Where do I want to see where those intersect? It looks like I should have 4 answers when I get done. Let's see if we can get there. Now that we've changed it to all tangents, this equation should be very similar to something we worked previously. So let's isolate this variable by adding 6 and dividing by 2. So we would get tangent squared theta equals to 3. Then of course we need to take the square root of both sides. And just like before, I'm going to go ahead and write those separately. Now between 0 and 2 pi, tangent is positive in 2 quadrants. In quadrants, I believe, 1 and 3. And it is negative in quadrants 2 and 4. And again, square root of 3 should be something you should have memorized on your unit circle. So when is the tangent of theta equal to the square root of 3? Or in other words, theta is the inverse tangent of square root of 3. You should get pi over 3. Now again, if your calculator is in radian mode, you're not going to get pi over 3, which is that exact answer that I'm going to require. But if your calculator is in degree mode, and you did this, it's going to tell you 60 degrees. It's not going to tell you that other quadrant. You would have to know to add 180, which is 240 degrees. But you've got to put your answers in radians. Actually, that's not in quadrant 3. 4 pi over 3 is in quadrant 3. Where is it negative? This is where, that's quadrant 2. That's quadrant 4. It doesn't really matter what order you put the answers as long as all of them are there. And so yes, we have 4 answers, and they're each between 0 and 2 pi, and they're expressed in radians. Let's look at the second example. The good news is that we have the same trig function, which is cosine. That we have the same angle, which is theta. So what do we need to do? Well, it looks like something we've done previously. It's quadratic, so we might think about factoring. But let's kind of substitute. How about if we let x be cosine theta? And so this is the equation we would need to solve. Can I factor that? No, it just doesn't factor. So if it doesn't factor, then we'd have to use the quadratic formula. Let's just review that quadratic formula. Now that corresponds to the general quadratic of ax squared plus bx plus c. But what is our x equal to in this equation? It's cosine. Now the coefficients are the same, so let's write that down. So we know x, we're going to substitute that as cosine theta, A is 1, that's the coefficient. B is -1, is right there, and C is -1. So we're going to have cosine theta, not x, but cosine theta equals to negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Now the only arithmetic I did is I squared the b. Let's keep going. So this is going to be 1 plus 4 over the square root of 2. So now I have cosine theta equals 1 plus the square root of 5 over 2. I have also cosine theta equals 1 minus the square root of 5 over 2. Let's go back and look at this graph. It's between 0 and 2 pi. Have the curve. Want to know when does it equal to 0. I should only get 2 answers. And I'm pretty sure they're going to be decimals because this is not in my unit circle. Now, how am I going to solve that? Well, go ahead, take your calculator very carefully and punch that in. Go ahead and round to 3 or 4 decimal places. You should get about 1.618. Let's go ahead and punch that in. Again, being very careful, you should get about -0.618. If you're using that TI-83 or really any calculator and you're punching in 1 minus the square root, some calculators go ahead and put that parenthesis. You'd have to close that parenthesis, and then if you just punched in divided by 2, that's going to be wrong. You're going to have to put that whole thing in parentheses to say the whole thing is divided by 2. Or 1 minus the square root of 5 and then punch enter or equals and then divide by 2. Just be careful. So that's your calculator lesson. Let's get back to this. If I take theta and I take the inverse cosine of this and I want to be in radian mode, what does your calculator tell you? It should tell you error, out of domain. And that is because, remember the cosine wave? What's its range? From +1 to -1. This is out of the range. Cosine can't be bigger than 1, so that's not possible. What about over here? So theta is going to be the inverse cosine of -0.618. Again, what does your calculator tell you? The calculator tells you that this is about 2.237. Well, where is that? Well, first of all, let's go back and think about where is the cosine negative. The cosine is negative in quadrants 2 and quadrant 3. As we come back up here to this graph, that means our 2 answers has to be between 0 and 2 pi because of our given restriction. Where are these 2 values? Well, 2 pi is about 6.28, so 2.237, believe it or not, is right here, and that is in quadrant 2. So how do we get our answer in quadrant 3? Well, we need to use some reference angles, so I kind of think about it like this. So 2.237 is all the way over here, and I need the angle that's all the way over here. So how can I find that? Well, I can go pi minus 2.237. And that gives me about 0.905, and that's my reference angle. So that means this angle down here is also 0.905. So how can I get it all the way around? I'm going to add pi to this, because pi is the same as like 180 degrees, but you're in radians. And so that gives you about 4.046. So we go back to this graph. So this is in quadrant 3, about 4.046. You will have one on the test where you have to use the quadratic formula. You can see it can be kind of confusing. You have to be careful punching things into your calculator, making sure you just use your calculator correctly, and then you have to make sure that those two answers are in the given interval. So number 3, we do not have the same trig function. We have sine and cosine. We also don't have the same angle. We have theta and 2 theta. It is usually easier to change the double angle into a single angle, so that's what I'm going to choose to do. So if you look at your list of identities for the cosine of 2 theta, you have some choices. You have ones with sine squared and cosine squared. That's not ever a good choice for trig equations. Your other one involves cosine, which is not a good one. We want to pick the one that just has sine. And we have that. So that's what I want to substitute. So I have 2 sine squared theta minus, that equals to 0. You want to distribute your minus sign, and we want to collect like terms. So going back to my picture, this is between 0 and 2 pi. We have the curve, and we want to see when does it equal to 0? 4 times. So I should get 4 answers. Let's see if we can get there. So let's isolate sine squared by adding 1 and dividing by 4. Then we're going to take the square root of both sides, and I'm going to do it just like I've done in previous examples. I'm going to go ahead and split that plus or minus sign. So the square root of 1/4 is plus or minus 1/2. Those are nice easy answers. Those are from my unit circle. I should have those memorized. Sine is positive in 2 quadrants. It's negative in 2 quadrants, and that's why I'm going to have 4 answers. So when is the sine positive 1/2? At pi over 6 and 5 pi over 6. When is it negative? At 7 pi over 6 and 11 pi over 6. So those are our 4 exact answers, no decimals, and the reasons why I didn't use decimals is because that value of half and negative half, something I should have memorized with my unit circle. This next problem is similar to number 3, except maybe not as difficult. We do have 2 different trig functions, but we have the same angle. So we need to get some identity that relates sine and cosine. And the only one I see is sine squared theta plus cosine squared theta equals to 1. So I'm going to solve for sine squared theta, and I'm going to substitute this in here. I'm going to go ahead and distribute that 2. And at this point I'm seeing quadratic because I see cosine squared. I like my squared terms to be positive, so I'm going to take this to the left. And of course that makes it positive. I'm going to subtract 2. I'm going to get plus 1. Definitely quadratic. Now I'm going to stop for a minute. Let's kind of go back up. Why do I have 2 pictures? Well, they're both between 0 and 2 pi. This first one, I graphed this curve and that curve, and I tried to see where they intersected, and I really couldn't see. They were on top of each other. I tried to zoom in. That didn't work. So then my second try was that I graphed this minus that equals to 0, and I see, well, it crosses at least 2. It either touches there or not sure. So that's why the algebra is important. Sometimes even when you zoom in on a calculator, it's just not real clear. But it gives us some indication that yes, we do have some answers. Now, let's go back to this problem. It's quadratic, so I'm going to kind of think of this problem where x takes the place of cosine theta. Can I factor that? I'd rather factor than use that quadratic formula, I think. So I think if it's all plus, that seems to factor, which means this factors. So instead of x, I would have cosine theta. Then we set both of those equal to 0 and solve for cosine. So I'm going to subtract 1 and divide by 2. And then I think, are those values for cosine something I should have memorized? Yes, it is. Okay. So when is the cosine negative 1/2? Remember, cosine's negative in quadrants 2 and 3. We should have memorized 2 pi over 3 and 4 pi over 3. You could put your calculator in degree mode and take the inverse cosine of negative 1/2, and it's going to tell you 120 degrees. It's not going to tell you that one over there. And you cannot leave your answer in degrees. The interval's in radians. When is the cosine equal to negative 1? Well, if you think about that graph of just your cosine wave, right, y equals cosine x, it's only equal to negative 1 at one spot, and that's at pi. So I have 3 answers. So right there, that must be at pi. This is at 2 pi over 3, and that is at 4 pi over 3. So my answers fit within the given interval.